In January 2023, the sky over California opened up and did not close for 3 straight weeks. Not a drizzle, not your typical rainy January, not even a really bad winter storm that makes the news for a day and then everyone moves on. This was something else entirely, something that weather experts later called a siege. Storm after storm after storm, rolling in off the Pacific Ocean like waves crashing against a wall that could not hold. Each one hitting before the last one was done. Each one adding water to rivers and streets and hillsides that were already full to bursting. For 3 weeks, it basically did not stop. By the time the skies finally cleared, more than 32 trillion gallons of water had fallen on a single state. Let me just stop right here, because that number means nothing to most people. Your brain reads 32 trillion and kind of skips past it the same way it skips past the national debt or the distance to another galaxy. It is just too big. So let me try to make it real. Take every single swimming pool in the entire United States. Every backyard pool, every hotel pool, every public pool, every Olympic training pool. There are roughly 10 million of them. Now fill every single one to the top. You're not even close. You would need to fill all 10 million pools more than 150 times over just to match the water that hit California in those 3 weeks. Or try another angle. Niagara Falls, one of the most powerful waterfalls on the planet, moves about 750,000 gallons of water every second. If you could somehow capture every single drop that goes over Niagara Falls and collect it into one giant tank, it would take you over a year and a half of non-stop flow to fill a tank equal to what California received in those 3 weeks. Still hard to picture? Okay, one more. California is a massive state. It covers about 163,000 square miles. That includes deserts, mountain ranges, entire cities, and farmland that stretches to the horizon. If you took all 32 trillion gallons and spread them perfectly flat across every single inch of that land, you would be standing in nearly a foot of water. Everywhere. On top of Mount Whitney. In the middle of Death Valley. On the Hollywood sign. Every square foot of the state underwater. That is how much fell. In 3 weeks. And here's the thing that really gets me. This was not a freak accident that came out of nowhere. This was not some once and forever event that nobody saw coming. This was a known weather pattern doing exactly what it has done before. Just harder and longer than anyone alive had ever watched it happen. 9 storms hit California back to back to back. Not 9 storms spread across the whole winter. 9 storms in less than a single month. Each one slammed into the state before the last one had finished draining. The ground was already soaked from the storm before. The rivers were already full from the storm before that. And the next storm would arrive anyway, dumping more water on top of a state that had absolutely no room left to hold it. Governor Gavin Newsom stood in front of cameras during the 8th storm and told reporters the state had already received somewhere between 22 and 25 trillion gallons at that point. And he was not rounding up for drama. He was not exaggerating. He was actually behind the final number because a 9th storm was still on the way. He used a word that stuck with me: stacking. He said the stacking of these storms was unlike anything California had experienced in living memory. And he said it while the rain was still falling, while people were still being rescued from flooded neighborhoods, while roads were still collapsing. By the time the sun finally came back, the real number had climbed past 32 trillion gallons. The San Francisco Bay Area had just lived through its wettest 3-week stretch in 161 years. To put a date on that, the last time that area got this much rain in 3 weeks, Abraham Lincoln was president. The Civil War had not even started yet. The toll was staggering. At least 21 people died. More than 400 people had to be rescued from their homes, their cars, their neighborhoods. The state's geological survey mapped more than 700 landslides. Roads cracked and gave way. Bridges flooded. Levees along the Cosmos River broke, sending water pouring across farmland and cutting off transportation routes. Entire towns were told to leave immediately with no time to pack. Bishop, a small city in eastern California, received more than its entire average yearly rainfall in the first 2 weeks of January alone. Think about that. A full year of rain in 14 days. San Francisco recorded measurable rain on 17 out of 23 days during the siege. 12 of those days had at least half an inch. 4 had more than a full inch. Day after day after day, the rain just kept coming. Multiple levees along the Cosmos River could not hold and broke open, flooding thousands of acres of farmland. Roads that people drive to work every single day were underwater. Neighborhoods that had never flooded before in anyone's memory were suddenly watching water climb toward their front doors. And yet, somehow, that is not even the strangest part of what those 3 weeks did. Here is the part that makes this story so hard to tell with just one emotion. Those same storms, the ones that killed people, destroyed property, and triggered a federal disaster declaration from President Biden, also saved California from a drought that had been choking the state for years. Before the storms hit, 43% of California was under the most severe categories of drought. Within about 3 months of the rain stopping, those categories were completely gone from the map, wiped out. The state's 2 biggest reservoirs jumped 66% in storage. 27 million people suddenly had more water flowing their way than they had been promised just 1 month earlier, back when drought was the headline. Before the storms, water agencies told Californians they would receive 5% of what they asked for. 5%. That is barely anything. After the storms, water allocations skyrocketed. The snow in the Sierra Nevada mountains was over double the historical average, which meant even more water coming as it melted through the spring and summer. The same water that destroyed property also filled reservoirs. The same weather event was both the worst thing and the best thing to happen to California that year. That is not spin. That is not a creative way to frame it. That is just what happened. And it is exactly what makes this kind of event so incredibly hard for a state to plan around. Now here's why I'm telling you this story right now in August. When the skies over California are dry and clear and wildfire season is the bigger worry on the evening news. Because what is coming toward California this fall and winter is not just another rainy season. Weather agencies are watching the Pacific Ocean right now, and what they are seeing has only happened a handful of times since we started keeping careful records. A Super El Niño is building. The same kind of Pacific Ocean pattern that drove the most destructive winters in California's modern history is forming again. And the forecasts are using a word you almost never hear in professional weather outlooks: unprecedented. I am going to break all of that down for you. How the storms actually form, why the ocean pattern matters so much, and what California has been doing since 2023 to get ready for the next one. But first, you need to understand the invisible weather system that made 32 trillion gallons possible in the first place. Because once you see how it works, everything else about this story clicks right into place. And later in this video, I'm going to walk you through exactly what you can do right now to protect your family before any of this hits. But if you do not want to wait, I put together something called the Family Disaster Survival System. It is a complete guide that covers everything from emergency planning to supply lists to exactly how to keep your household safe when a major weather event shows up with little warning. The link is in the description and pinned in the top comment. You can grab it right now and come back. But if you want the full picture of what is actually heading toward California first, stick with me. Let's get into how a river can float in the sky. Section 2, Rivers in the Sky. So here's the thing that most people do not realize about California's biggest storms. The water does not just appear out of thin air above the state. It travels, sometimes thousands of miles, and it travels in something called an atmospheric river. That name sounds fancy, but it is actually very literal. Think about a regular river. It has banks, it flows in one direction, it carries water from one place to another. An atmospheric river does the exact same thing, except it flows through the sky instead of along the ground. You cannot see it with your eyes, you cannot hear it, but it can be absolutely enormous. A typical atmospheric river stretches over 1,000 miles long, but is only a few hundred miles wide. It is like a giant fire hose in the atmosphere, pointing from the warm tropics straight at the California coast. And instead of carrying liquid water, the way a river on the ground does, it carries water vapor, moisture. Invisible wetness pulled up from the warm ocean surface near places like Hawaii or the equator, then dragged thousands of miles through the air by wind patterns. And here is the number that always stops people. A single strong atmospheric river can carry as much water through the air in a single day as the entire Mississippi River carries on the ground. Think about that for a second. The Mississippi is one of the biggest rivers on the planet. Its watershed reaches 32 states, and one invisible corridor of moisture floating above the Pacific Ocean, completely hidden from view, can match that flow. The strongest atmospheric rivers go even further. Some carry 7 to 25 times more water than the Mississippi. A study from MIT estimated the moisture flow of a major atmospheric river at roughly 176,000 tons of water per second. That is the same moisture flow as the Amazon River, which is the biggest river on Earth by volume. Globally, atmospheric rivers are responsible for about 90% of all the moisture that moves from the tropics into higher parts of the world. They are literally the planet's main water delivery system. And this is not some rare, once-in-a-century event. This is California's normal water delivery system. In a typical year, atmospheric rivers deliver about 30 to 50% of all the rain and snow the entire West Coast gets. Without them, California would be permanently dry. The reservoirs would be empty. The Sierra Nevada snowpack that feeds cities and farms all through the summer would be a fraction of its size. The entire agricultural economy of the Central Valley, one of the most productive farming regions on Earth, depends on atmospheric rivers showing up every winter and dropping enough rain and snow to keep everything going. So they are not unusual. They are necessary. They are basically California's entire water supply in cloud form, delivered once a year by an invisible sky river. If you turned off atmospheric rivers, California would become a desert within a few years. No snowpack, no reservoir refills, no water for 40 million people. That is how important these things are. And about 80% of all flood damage on the West Coast comes from atmospheric rivers, too. The same system that keeps California alive is also the system most likely to devastate it. That split personality is baked into the very nature of how the state gets its water. You might have heard the term Pineapple Express on the weather forecast before. That is actually a specific kind of atmospheric river. It gets its nickname because it pulls tropical moisture from the warm ocean near Hawaii and launches it straight at the West Coast. When a forecaster says Pineapple Express incoming, what they are really saying is a massive atmospheric river loaded with Hawaiian moisture is about to slam into the coast. Same thing, catchier name. The problem is when these sky rivers show up too strong, too many at once, or right on top of each other with no break in between for the ground to absorb what already fell. And that is exactly what turned a normal winter pattern into the 32 trillion gallon siege of January 2023. Here's how the destruction actually works, step by step. That corridor of moisture, that invisible river in the atmosphere, comes flying across the Pacific Ocean. It hits the California coast. And right there behind the coast sit mountains, the Sierra Nevada, the Coast Ranges. These mountain walls act like a giant ramp. They force all that moisture upward. And as it rises, the air cools down. This is where basic physics takes over. Warm air can hold a lot of moisture. Cold air cannot. So when that warm, soaking wet atmospheric river gets shoved up and over the mountains and the temperature drops, all that water vapor that traveled thousands of miles suddenly has to go somewhere. It condenses, it turns into liquid water or ice, and it falls. Rain at lower elevations, snow higher up in the mountains. And because the atmospheric river keeps flowing behind it like a fire hose that nobody turned off, the rain keeps falling, sometimes for days without stopping. When this happens once, California gets a good solid storm. A few inches of rain over a couple of days, some rivers rise, maybe a creek floods, standard winter weather. But when it happens 9 times in a row, in less than a month, with no time between each event for the ground to drain, something very different happens. The soil maxes out. It cannot absorb anymore. Every additional drop of rain runs straight off the surface into streams and rivers that are already at capacity. Hillsides that are already waterlogged lose their grip and slide downhill, taking homes and roads with them. Storm drains that are working at full speed simply cannot handle another wave. Think of it like a bathtub. If you turn the faucet on for 5 minutes and then turn it off, the water drains just fine. But if you turn it on, wait 2 minutes, then turn on a second faucet, then a third, then a fourth, and you never turn any of them off, the tub overflows. It does not matter how big the tub is. If water comes in faster than it can drain, eventually everything spills over the edge. California, in January 2023, was that bathtub. And 9 atmospheric rivers were 9 faucets, each one pouring in before the last one finished draining. That stacking is the key to understanding 32 trillion gallons. A single atmospheric river is manageable. 9 of them back to back with no recovery time is a statewide flood emergency. Scientists now rate these events on a scale that works a lot like the hurricane rating system. It runs from AR1 at the low end, which is a weak event that mostly just brings helpful rain, all the way up to AR5, which is an extreme event that can cause hundreds of millions of dollars in damage. The scale was created in 2019 by a researcher named Marty Ralph at the Scripps Institution of Oceanography, and it measures 2 things: how much moisture the river carries and how long it sits over one spot. During the January 2023 sequence, individual storms in the chain rated at AR3 and AR4, dangerous on their own. But the problem was not any single storm, it was the chain, 9 of them, no breaks. And as wild as 2023 was, it was not the worst California has ever seen, not even close. In the winter of 1861 to 1862, long before anyone knew what an atmospheric river was, a chain of storms hit California for over 40 straight days. The entire Central Valley, a region 300 miles long and 20 miles wide, turned into an actual inland sea. Boats were the only way to travel. Governor Leland Stanford had to row a boat to his own inauguration in Sacramento. When he came home afterward, he had to enter his mansion through the second-story window because the first floor was underwater. 1 out of every 3 properties in the state was destroyed. A quarter of all cattle in California died. The ranching industry that had been the backbone of the state's economy was basically wiped out overnight. And California shifted permanently from a ranching economy to a farming economy because of it. The state government went bankrupt. California's economy shrank by 25%. Scientists estimate roughly 4,000 people lost their lives. And the Native Americans, who had lived in the Central Valley for generations, were not surprised. Their oral traditions talked about the valley becoming an inland sea when the big rains came. Stories passed down for centuries described water filling the valley from the Coast Range to the Sierra. They already knew this could happen. The settlers who built Sacramento in a floodplain did not. Modern researchers confirmed years ago that this disaster was caused by the exact same thing: a long chain of atmospheric rivers slamming into California one after another, just like 2023, but stretched across 40 days instead of 3 weeks, and with no modern flood infrastructure in place to absorb any of it. And just in case anyone thought 2023 was a one-time thing that would not repeat, California got slammed by more atmospheric rivers in February 2024. Downtown Los Angeles recorded over 8 inches of rain in just 3 days, making it the second wettest 3-day stretch in the city's recorded history. Death Valley, one of the driest places on the entire planet, got so much rain that the park had to close roads. Over 300 more landslides were reported across the state. It was not as extreme as the January 2023 siege, but it was another reminder that this pattern does not just happen once and disappear. So the question is not whether something like this can happen again. History has already answered that. The real question is what makes the difference between a helpful wet season and a catastrophic one. And the answer, more than anything else, is the Pacific Ocean. Which brings us to the part of this story that should have every Californian paying very close attention right now. Section 3, the monster in the Pacific. To understand why forecasters are already nervous about this coming fall and winter, you need one more piece of the puzzle. And honestly, it might be the most important piece. Everything about atmospheric rivers, how they form, where the moisture comes from, how strong they are, how many of them line up in a row, all of that depends on what the Pacific Ocean is doing. The ocean is the engine that powers California's entire storm season. And right now, that engine is heating up in a way that has scientists reaching for the history books. There is a climate pattern called El Niño. You've probably heard the name thrown around on the news, but most people hear El Niño and think it just means a warmer winter or maybe some extra rain. That is like hearing Category 5 hurricane and thinking it just means a windy afternoon. Here is the simple version. Think of the Pacific Ocean as a giant bathtub that is slightly tilted. In a normal year, the water near the equator is warm on the western side, near Australia and Southeast Asia, and cooler on the eastern side near the Americas. Big trade winds blow across the surface and keep pushing that warm water toward the western end. Everything stays more or less balanced. The warm water stays over there. The cooler water stays over here. The weather patterns that depend on this setup do their normal thing. During an El Niño, those trade winds weaken. Sometimes they almost stop completely. And sometimes they actually reverse and start blowing the other direction. When that happens, all that warm water that was being pushed toward Asia starts sliding back eastward toward the Americas. It piles up along the equator, and the ocean surface in the central and eastern Pacific gets much warmer than it should be. We are talking about water temperatures climbing 2 to even 3 degrees Celsius above normal. That might not sound like much, but in ocean terms, that is massive. The ocean holds an almost unbelievable amount of heat, and even a small temperature change across a region that huge releases enormous amounts of energy into the atmosphere above it. That extra warmth changes everything above it. It pumps more energy into the atmosphere. It shifts where storms form and where they travel. It bends the jet stream, which is basically the highway that storms ride along across the Pacific. And for California specifically, a strong El Niño takes that jet stream and points it south. Instead of sending most of the rain into the Pacific Northwest, it aims the storm track directly at California, like adjusting a garden hose to point right at one spot in the yard. Now here's where this year becomes a really big deal. In June 2026, NOAA upgraded the forecast to an El Niño advisory. By mid-July, the Climate Prediction Center dropped a bombshell. There is a 97% chance this El Niño will last all the way through spring 2027, and there is an 81% chance it will grow to become very strong. That is the official term for what everybody else calls a Super El Niño. Super El Niños are rare, genuinely rare. Since 1950, when we started keeping detailed records of this pattern, only a small handful have ever reached that level. The most famous ones hit in 1982 to 1983 and 1997 to 1998. Both reshuffled weather patterns across the entire planet. Both brought some of the most extreme weather California had ever recorded, and both left marks on the state that people still talk about decades later. The 1982 to 1983 event is remembered for devastating coastal storms that destroyed property all along the California coast. A state task force documented massive storm and flood damage from that single winter. During the 1997 to 1998 Super El Niño, California received roughly double its normal rainfall across large parts of the state. The San Francisco Bay region alone suffered over $150 million in landslide damage. 17 people died in storms statewide. The warm ocean water literally expanded, raising sea levels along the coast by several extra inches, and when that combined with storm surges and low-pressure systems, neighborhoods that had never flooded before were suddenly watching the ocean pour into their streets. Highway 101 north of the Golden Gate Bridge was under 4 feet of water from San Francisco Bay. And on the Central Coast, some areas recorded over 40 inches of rain in a single season when they normally get around 20. Scientists at the USGS later confirmed that the ocean itself had risen by about 6 inches above normal as early as May 1997 from warm water pulses called Kelvin waves. By late fall, water temperatures off the California coast were far above normal, down to depths of 300 feet or more. The thermal expansion from that warmth, basically warm water taking up more space than cool water, added another 8 inches of sea level rise. So even before the big storms arrived, the ocean was already higher than it should have been, which made every storm surge, every high tide, every coastal flood that much worse. Now, every model that NOAA runs is projecting that the 2026 to 2027 El Niño could rival or exceed those events. All 30 members of NOAA's experimental forecast system agree. Every single one projects a very strong El Niño peaking this coming late fall and early winter. The atmospheric scientist Michael Tippett at Columbia University recently told CNN that the forecasts are close to unprecedented. Daniel Swain, a well-known climate scientist at UCLA, described it as having a high chance of being the real deal with large global effects. He explained that a strong El Niño releases stored ocean heat into the atmosphere and creates what he calls a mini, temporary, but natural global warming on top of the warming that is already happening from climate change. California's own Southern Operations Fire and Weather Agency published their seasonal outlook on July 30th, 2026, covering August through November. The language is technical, but the message is clear. As California transitions from dry season into wet season, conditions will be warm and atmospheric rivers are considered likely. That is, the agency responsible for planning storm response resources across Southern and Central California. They are not guessing. They are not speculating. They are telling their own people to get ready. And this year's water data already tells part of the story. California's statewide precipitation through the end of April 2026 was right at about 100% of average. That sounds normal, and it is. But it means the ground is not dried out and starved the way it was before the 2023 siege. If a big atmospheric river season hits this winter, it hits ground that is already in decent shape, which means faster runoff and higher flood risk in many areas. A local meteorologist on the Central Coast laid out the timeline even more clearly. Summer 2026, the transition begins. Fall 2026, El Niño typically strengthens and atmospheric rivers could arrive earlier than usual. Winter 2026 into 2027, historically strong El Niño events have brought 150 to 200% of normal rainfall to the region, with serious flooding risks along major rivers and coastal areas. Now I want to say something important. A Super El Niño does not guarantee a repeat of 2023. It does not automatically mean another 32 trillion gallon siege is locked in. The Climate Prediction Center said it clearly. Even the strongest El Niño events do not create the typical impact everywhere. Weather is complicated and local conditions always matter. But what a Super El Niño does is load the dice. It takes the odds of a wetter, stormier, more dangerous winter and pushes them heavily in that direction. And it does so based on the exact same ocean pattern that preceded the worst winters California has on record. Bay Area communities are already stepping up their flood preparations months before the wet season even begins. Local governments are checking levees, clearing drainage channels, and running through emergency plans. They are not doing this because someone told them to panic. They are doing it because they lived through 2023. They know what stacking atmospheric rivers can do to a region that is not ready, and they know that this time, the Pacific Ocean pattern behind the forecast is even stronger than it was 3 years ago. That is not hype. That is what the data shows. And it is what the people whose job it is to forecast and plan for these events are telling us right now. Section 4. The race to catch the rain. There's a strange truth about California and water that most people outside the state do not fully appreciate. California does not have a water problem. It has a timing problem. The state swings between two nightmares, too little water for years at a time, with droughts that dry up farms, drain reservoirs, and force cities to ration every drop. And then suddenly, sometimes in the span of just a few weeks, too much water all at once with floods that destroy everything in their path. And the cruelest part is that both nightmares often come from the exact same storms. The same rain that kills people also fills reservoirs. The same floods that destroy roads also end droughts. The same atmospheric rivers that trigger federal disaster declarations also deliver the water that 40 million people and one of the world's largest agricultural industries depend on for survival. Climate scientists have a name for this. They call it weather whiplash, the violent swing from one extreme to another in a time frame that no human system is really built to handle, and California might be the single best example of it on the planet. In December 2022, California was deep in drought. Reservoirs were dangerously low. Water agencies told 27 million people they would get just 5% of the water they had asked for. 5%. That is barely enough to keep the system running. 3 weeks later, the atmospheric river siege had dumped 32 trillion gallons and the drought was basically over. Reservoirs jumped 66%. The Sierra snowpack was at more than double the average. The same state that was rationing water was suddenly swimming in it, and most of it just ran off, down the mountains, through the valleys, into creeks and rivers already at flood stage, out to the ocean, gone. That is the detail that haunted California's water managers after the storm stopped. Not the damage, though that was terrible, but the realization that trillions of gallons of water the state desperately needed had just washed through too fast to capture. Like trying to fill a cup from a fire hydrant. Most of it just blasts past. So since 2023, California has been working hard on that problem, and the progress is real. The state has poured more than $8.6 billion into what they call water resilience. That means getting better at catching floodwater and storing it for later instead of watching it run to the sea. The biggest strategy is called groundwater recharge. The idea is beautifully simple. California sits on top of massive underground water basins. Natural rock formations deep beneath the surface that work like a giant hidden sponge. These underground basins can hold 8 to 12 times more water than all of California's above-ground reservoirs and lakes combined. All that empty space sitting right under the state's feet, just waiting to be filled. During normal rain, some water seeps down naturally. But during a flood event that drops trillions of gallons in weeks, the water moves across the surface way too fast to soak in. It just runs off. So, California started building infrastructure to slow that water down and push it underground on purpose. New canals to divert excess river flow, temporary pumps and siphons deployed along rivers in the Central Valley that literally pull floodwater off the surface and redirect it into recharge basins. Farmland in places like the Dunnigan area of Yolo County was intentionally flooded to let the water soak down into the earth and refill the aquifer below. Governor Newsom signed executive orders to fast-track recharge permits that had previously taken years to get through the system. The state streamlined the entire approval process so that when the next big storms hit, local water agencies could act within days instead of waiting through months of paperwork. The Fresno Irrigation District deployed temporary diversion equipment along the Kings River in April 2023, pulling excess floodwater off the river and directing it into recharge zones before it could rush downstream and cause more damage. And the results in 2023 were impressive. California managed to push 4.1 million acre-feet of water into underground storage through managed recharge that year. That single year of effort stored enough water for 26 million households for an entire year. And for the first time since 2019, the state's overall groundwater storage actually went up instead of continuing its long decline. But the gap is still huge. Over the past 20 years, California's underground basins have lost nearly 40 million acre-feet of water. That deficit is so large, it would take many wet winters of aggressive recharge to fully close. And that is part of why this El Niño season has water managers watching with a strange mix of hope and dread. Hope, because a wet winter means more water to capture and store. Dread, because if the storms come too hard and too fast, the very infrastructure designed to manage them can get overwhelmed or damaged. California is also building brand new storage. The site's reservoir project, when completed, will hold up to 1.5 million acre-feet of water. That is enough for about 3 million homes for an entire year. It is specifically designed around the idea of catching water during extreme wet seasons and holding it for the dry years that always follow. The state is also pushing forward on the Delta Conveyance Project, which will improve how water moves through the Sacramento-San Joaquin Delta and protect water access for 27 million Californians. But here's the tension. These projects take years to build. Some are still in planning. And the Super El Niño forming right now in the Pacific is not on anyone's construction timeline. It is building on its own schedule. The warm water is spreading. The models are climbing. And whether California is ready or not, this winter is coming. So the real question, the one that keeps water managers up at night, is whether the systems California has upgraded since 2023 are enough to handle what might be headed their way. Can they catch enough of the next flood to make a dent in that 40 million acre-foot deficit? Or will the state once again watch trillions of gallons of desperately needed water rush through too fast to grab? That answer depends on something nobody can control. How many atmospheric rivers show up, how strong they are, and whether they stack. Section 5. What you can actually do right now. Let me bring this all the way down to earth, because none of the big numbers matter much in the abstract. Not 32 trillion gallons, not 81% odds of a Super El Niño, not billions of dollars in infrastructure spending. What matters is what it means for real people in real places. If you live in California, this is the best possible time to think about your flood risk, right now, while the sun is out and the ground is dry and no storm is anywhere on the map. because the pattern that delivers the heaviest rain to California does not give a lot of warning at the individual storm level. Forecasters can see the big picture months out. They can say, this is going to be an active atmospheric river season. But the exact timing of a specific storm, the one that drops 6 inches of rain on your town in 2 days, that only becomes clear about 1 to 2 weeks before it actually forms. That is just how these systems work. So the time to get ready is now, while the sky is still blue. And getting ready does not mean panicking. It means checking a few simple things. Do you know if your home is in a flood zone? You can check this for free in about 2 minutes on FEMA's flood map website. A surprising number of people discover they are in a moderate or high-risk zone and had no idea. If you live near a hillside that burned in a recent wildfire, pay extra attention. This one really matters. When a wildfire burns through an area, it does not just remove trees and bushes, it actually changes the soil itself. The intense heat creates a waxy layer in the ground that stops water from soaking in. So when a strong atmospheric river dumps inches of rain on a burn scar, the water hits that sealed surface and runs straight downhill, picking up loose dirt, rocks, and debris as it goes. The result can be a devastating debris flow that moves faster than a person can run. This exact pattern has played out over and over again in California. The deadly Montecito mudslide of 2018 happened when a moderate rainstorm hit slopes that had just been burned by the Thomas Fire. 23 people died. The rain itself was not even that extreme. But the burn scar turned a normal storm into a catastrophe. And California has had massive wildfire seasons in recent years, leaving burn scars all across the state's hills and mountains. Do you have basic emergency supplies? Nothing extreme, just flashlights, batteries, some bottled water for a few days, a plan for where you would go if you were told to leave quickly, and a way to charge your phone if the power goes out. Small, easy things that make a massive difference when the rain does not stop. If you own your home, take a walk around the outside while the ground is still dry. Look for low spots where water collects, check your gutters and downspouts, make sure nothing is blocking the path water needs to take away from your foundation. These things cost nothing but a few minutes, and they matter a lot when a storm parks over your town for 3 straight days. And here is something most people do not think about until it is too late. Check your insurance. Standard homeowners insurance in California does not cover flood damage. You need separate flood insurance for that, and in most cases, there is a 30-day waiting period before a new policy kicks in. If you wait until a storm is already on the map to buy flood insurance, you will not be covered in time. That 30-day clock needs to start now. None of this requires believing a mega event is definitely coming to your neighborhood this winter. It just requires treating the forecast the way people along the Gulf Coast treat hurricane season. You do not wait for a specific hurricane to be on the radar before you check your insurance and your shutters. You do it during the quiet months, when nothing is happening, is exactly when preparation makes the most difference. Right now, California is in its quiet months. Dry, warm. Fire season is the bigger concern on today's news. But the Pacific Ocean is not paying attention to today's news. The warm water is already spreading across the equator. The forecast numbers are already climbing. NOAA has already upgraded to an advisory, and every model is trending toward the same conclusion. Whether this coming wet season brings a gentle parade of helpful storms that fill reservoirs and build a healthy snowpack, or another historic siege that stacks atmospheric rivers back to back with no recovery time, that answer is still being decided by ocean temperatures and wind patterns thousands of miles away. What is settled is that the odds have shifted. The same engine that powered the worst winters in California's recorded history is firing up again, and the forecasters watching it are running out of ways to say, this is a big one, without causing panic. The difference between someone who gets caught off guard by a flood and someone who handles it calmly is almost never luck. It is information. It is knowing what is coming and taking a few simple steps before it arrives. And now you have that information. You know what 32 trillion gallons actually means. You know how invisible rivers in the sky deliver it. You know that a rare and potentially historic Super El Niño is building in the Pacific right now. And you know that California's own agencies are already watching and planning for what it might bring. What you do with that knowledge between now and the start of the wet season is up to you. That is the full picture. 32 trillion gallons falling on a single state. Invisible rivers floating across the Pacific, carrying more water than the Mississippi. A Super El Niño forming right now that could rival some of the strongest on record. And a state racing to upgrade its systems before the season arrives. If this helped you actually understand what those numbers mean and why this season matters, hit that like button. Now look, I walked you through the big picture in this video. The science, the history, the forecasts, but the part that actually protects your family is the stuff you do at home before any of this arrives. That is exactly why I created the Family Disaster Survival System. It takes everything I just talked about, the flood risk, the emergency planning, the supply preparation, the insurance timing, and puts it into one clear step-by-step guide that you can work through this week while the sun is still out and you have time to do it right. No panic, no guessing. Just a simple system that makes sure your household is ready when the season turns. The link is in the description and pinned in the top comment. Grab it now while this is fresh on your mind. One question before you go. If you are in California or you know someone who is, what worries you more about this coming season, the flooding or the drought that always follows after? Drop your answer in the comments. I read every single one, and I think that split says a lot about how complicated this story really is. I will see you in the next one.